Howdy. I was watching a bit weather. Climate Prediction Center, National Weather Service, Northern Hemisphere. This is this widget loop, a 30-day loop of analyzed 500 hectopascals height and anomalies. Each frame is a 5-day mean centered on the date indicated in the title of 500 hectopascal heights and anomalies from NCEP Climate Data Assimilation System. Contour interval for heights is 120 meters. Anomalies are indicated by shading. Anomalies are departures from the 1991 to 2020 daily base period means. The reds are high pressure system cells, the blues are low pressure system. This is a loop you cannot stop, so I made a screen video. So that's the screen video I made. And if we go to the day of, or the last day, sixth, so it's the 9th of this month, which is the last one. Here we have Florida, Gulf of Mexico, Greenland, Europe. There is a high pressure system. There is some bluish here, but that's still in August. And if we go to the last day, it has is recorded 9th of September. There is here some darker blues, and here is also blue. And if we go to the beginning of that, we start now at 31st August. And I want to point out how this region, maybe it's something like that, starts to get blue. 31st August, 2nd September, we have strong high pressure systems there. 6th, this is a storm raging now in Europe. 7th, 8th, 9th. And somehow it seems that this region here might gain in strength. And since there were no hurricanes in America whatsoever, some of them, they spin around and came back to Europe. And there is some more going on there at the moment. Probably there's a third one coming also, because it seems it doesn't really move. So, and I was stumbling across an article on severe weather Europe. A polar vortex is now emerging in the stratosphere over the North Pole and will impact the weather as we head closer to winter 2022-2023. The polar vortex doesn't emerge. It's always there. It's our connection to the sun and so on. A polar vortex is now emerging in the stratosphere over the North Pole. It began forming as seasonal cooling intensified and will continue to strengthen well into the winter of 22-23. It's always like that. Since Earth is or has come into existence. With a long history of winter weather impacts over the United States and Europe, it's being closely monitored throughout every fall and winter. Yeah. As you will see, there are many layers of the polar vortex and different weather outcomes it can produce, but regardless of strong, weak, or collapsed, it always plays an important weather role. Maybe some of you are aware that the days are getting shorter, Earth starts to spin faster. there is much more output from the sun since many years. There has been the biggest solar eruption ever recorded just a few days back. The sun seems to wake up. We are entering the great turnover in terms of sun cycles. 12,000 year sun cycle is upon us, which is a half cycle. And then we have the quarter, which is 6,000 years. And many tales have been told about this. We have Noah's Ark at the Great Deluge and all these kind of things. The whole mysticism world and with the gods and all these kind of things. 6,000 years. Jesus had 2 fish. Everybody knows that. Because he was representing the age of Pisces, which is about to end. It already started to end because I'm not very sure which planets, Uranus, Jupiter, are already in the sign of Aquarius, which is the next sign after Pisces. So it might be excited to see who is representing the age of Pisces, because the time of Jesus is over. Just look at the calendar. So this kind of polar vortex strange talk doesn't really make sense. It is a cosmological Birkeland current which connects us with the sun and therefore with the rest of the universe. And all the things are fluctuating. This is what the cycles are. There is more output from the sun, there will be more output from the earth. There has been a 7-pointer earthquake. Was it Indonesia, Papua New Guinea, somewhere there? We had yesterday. For Central Europe, very strong earthquake activity, and it's still ongoing. I really wonder how many quakes, aftershocks, or however you want to call it, they don't show anywhere. There might be many. The image below shows one of the strong polar vortex events from a few winters back. Such a near circular shape usually means strong stratospheric circulation. But first, what is the polar vortex? Why do we care about it? And why should you? So you probably notice that's also pictured from above. It has this shape, which is similar to this, just in a different way. And that's from now, so we are not even at the fall equinox. And this will change. And you can see it's rotating. But anyway, let's go back to this a bit. I think that's very long. I didn't read the whole thing, but when the North Pole starts cooling, as we head into autumn, the polar regions start to receive less sunlight. With less solar energy, temperatures begin to drop and seasonal cooling begins over the pole. But as the polar temperatures drop, the atmosphere further to the south is still relatively warm as it continues to receive light and energy from the sun. You can see the winter solstice in the image below. The polar regions receive little to zero solar energy compared to regions further south, which still receive plenty of sunlight and warmth. Winter solstice. It's in the shadow. So the sunbeam has to make a stronger turn, or however you put it. And here it's more directly. But as the temperature drops over the polar region, so does the pressure. This process is the same on the surface and up to the stratosphere and far beyond. You can see the layers of the atmosphere in the image below. The troposphere, blue layer, and the weather are on the bottom. And the stratosphere, green layer, with the ozone layer above it. Remember, we are just watching 100 kilometers, which is the ionosphere E layer. And we are down here. This is where the plane flies, 10 to 12 kilometers, but it's going up and up and up. There's like plenty of space. Plenty of space left. And taking another step back, we can watch the bow shock, magnetosphere, polar cusps. So the atmosphere, what they were showing here in the article, you probably couldn't even see on this map. And these are the Birkeland currents I was talking about, which create the polar and Antarctic currents, vortices, of which we are reading in this article. This causes a strong global pressure difference between the polar and subtropical regions. Now I pressed some. And large low pressure and the large low pressure cyclonic circulation starts to develop across the northern hemisphere. It extends from the surface layer far up into the stratosphere. This is known as the polar vortex. The polar vortex is a Birkeland current, and one specific. What was the word? No, I don't remember. The specific thing about Birkeland currents is his counter-rotation feature. Yeah, maybe it was the word feature. I don't know. Birkeland currents. This is ESA, European Space Agency, 2017. ESA swarm has been used to improve our understanding about vast sheets of electric current in the upper atmosphere. Birkeland currents carry up to 1 terawatt of electric power to the upper atmosphere, about 30 times the energy consumed in New York during a heat wave. They are also responsible for aurora arcs, the familiar slow-moving green curtains of light that can extend from horizon to horizon. Recent observations by SWARM have revealed that they are associated with large electrical fields and occur where upwards and downwards Birkeland currents connect through the ionosphere. Scientists have also discovered that these strong electric fields drive supersonic plasma jets. Another feature of plasma filaments moving Birkeland currents and such are Diochotron instabilities. A Diochotron instability is plasma instability created by two sheets of charge slipping past each other. Energy is dissipated in the form of two surface waves propagating in opposite direction, with one flowing over the other. The instability is the plasma analog to Kelvin-Helmholtz instability and fluid mechanics. So there's a video. And now, back to this video. That's exactly the same thing. These blobs are the Diochotron instabilities, and the whole thing is spinning. That's why they are moving around. So the weather patterns are affected by the cosmological or like interplanetary Birkeland currents, Birkeland current which connects us to the sun. Earth, sun. There is always energy going both ways, constantaneously, between our mother star and planet, and all the other planets have the same thing. This is how they maintain connection. Besides that, if that's the sun, and what is it? I can't get it into my head, the most outer sphere of our sun. But all the planets, Venus, Jupiter, Saturn, Earth, moons, and all this stuff is within the sphere of the sun. And the sun has Birkeland currents which connects it probably the center of our galaxy. Scalability, the same thing. Exactly the same thing. So the bigger currents which connect the sun to the center of our galaxy are dictating the weather of the sun. And if the weather on the sun is getting bad, the weather on Earth is getting mad. And this happens in certain cycles, 12,000, 6,000 and such. Yeah, Diochotron instabilities. And of course, the closer you go to the surface of the Earth, the more surface conductivity anomalies or magnetic anomalies and all these things, different charge potentials in the ground or whatsoever, what you have. Maybe also very big electricity facilities could have certain effects on weather pattern as well, as Earth magnetosphere is weakening and is more vulnerable to changes in geomagnetic activity, which allows to make electromagnetic connections to places probably haven't seen ever before. Because Earth's magnetic field was so strong, it just protected us, but it's weakening and the poles are shifting. So there's like so much stuff going on and so much surprises still waiting around the corner for humanity. Just alone by weather. But anyway, I leave it here. Yeah, thanks. See you next time. Bye.